Hi, welcome to this video. We are looking at quadratic equations today. Uh, so we'll be looking at recognizing them. We'll be looking at solving them. We'll solve them 4 different ways. And we'll do just one applied problem at the end. Today's picture is of the Bieber Bridge. I don't know why they called it that. It's a bridge that goes over this swampy kind of thing out in Ontario. Okay, so in the last section we were looking at linear functions, and we saw that with linear functions they had a slope and they have a y-intercept, and those are the characteristics of linear functions that we want to know. They sort of characterize or define linear functions. When we look at quadratic functions, we're looking at other things. Let me just graph on decimals, and it'd be a good idea to be friends with decimals as you're doing this. So if I were to graph a linear function, say 2x minus 9, there we go. So you can see the function, and you can see where it crosses the y-axis, right down there. And you could, if you wanted to, figure out what the slope is. It'd be up 2 over 1, up 2 over 1, up 2 over 1. So that's a linear function. When we turn our attention now to looking at quadratic functions, like this one, y is equal to, let's go, x squared minus, I don't know, 3x minus 9. There we go. So the blue one there is a quadratic function. There's different characteristics of a quadratic function. Today, when we solve any quadratic equation, what we're looking for is that point and that point right there. We also, and you can't really see it real well, but we also want to know what the y-intercept is. But when we're solving a quadratic equation, we are getting those numbers right there. Okay, just as we start talking quadratics, there's 3 terms that you sort of want to be familiar with. One of them is if I see an x squared, and that's the highest degree in an equation, this would be known as a quadratic something. If it's equal to 0, like this, then I call it a quadratic equation. If there's a y involved, then I'm looking at a relationship between x and y, and so it's a quadratic relation. If we replace the y with an f of x, then I would call it a quadratic function. And there's different times, these two are very much related, but there's different times when we want to use each one of the terms. Keep in mind, though, that to solve any quadratic equation or to find the x-intercepts of any quadratic function, you're doing the same thing. And the same thing are these next 4 things that I'll show you. So just before we get into those 4 things, I wanted to just mention 1 or 2 things about functional notation. What we're doing in this section is we're solving for a quadratic function, and what we do when we're trying to solve the x-intercepts of a quadratic function, we're letting f of x equal 0. So this first one, I have 0 is equal to 7x plus 12. It could have started like this. So there's a function, and what I want to know is I want to know what the zeros of the function are. And so I replace f of x with a 0. Okay, and then I solve that equation. And when I solve that equation, what I'm doing is looking for x-intercepts. Let's just do it here in decimals, if decimals will work today. Come on. Oop. Here we go. So y is equal to x squared plus 7x plus 12 plus 12. There we go, right there. So what I'm looking for when I solve is I want to figure out what this point is right there and that point right there. So when I solve this quadratic equation, the one with the 0 in it, I'm looking for those 2 points. Now, you might have seen function notation that looks like this, and when they say f of 2, what they're saying is, if I have an x value of 2, what is my y value? And so what you do is you plug a 2 in everywhere you see an x. This would come out to 4 plus 14 plus 12. So 4 plus 14 would be 18 plus 12. I think that comes out to 30. So the value of the function, when you plug a 2 in for x, it comes out to 30. Now, let's see if that's right. Like x is 2, you find where x is 2, right up there. Yeah, you see it? So x is 2, 1, 2, and the y value, it's up 30. Okay, so that's what those two things mean with functional notation. So now, the next four things that we're going to do is to try and solve this equation mathematically. It's always a good idea to check it with decimals, and maybe sometimes start with decimals, and that might help if you want to know if your answer is correct or not when you do the math part of it. Okay, the first one is why we factor. And it's called the principle of zero products. It says that if the product of two things is equal to 0, then one of those two things has to be equal to 0. So if I can change this into a product of two things, then I can figure that out. So this question says find the x-intercepts where it crosses the x-axis by finding the solutions for this. So I'm going to put a 0 in for f of x. And now what I want to do, x plus 12, what I want to do is I want to get this so it's the product of two things. And to do that, you factor. So x and x, two things that multiply to 12, add to 7, plus 3 and plus 4. Okay, and then you can equate both of those factors to 0 and then solve the equation. Okay, so factoring, the principle of zero products, that's why we learn how to factor, is so that we can use the principle of zero products. Now let's just graph this and see what it looks like. Okay, so I'm going y equals, I think you can do 0 equals 2, but I'm going to do y. Y is equal to x squared over plus 7x plus 12. Okay, let me zoom in. You can zoom in on that if you just take two fingers and zoom. And sure enough, the place where it crosses is at a -3 and a -4, and that's what we got over there. Why don't you try one? So find the x-intercepts by plugging a 0 in for this. Oh, press pause, then try it, then press play and see if you're right. Okay, so I need to factor this side. I think it'll be a 2x and an x. You can factor this with the AC method if you'd like, or I like to use guess and check. I think this would be a +4 and this a -1. 2x squared plus 8 minus 7, yeah, -4. Yeah, that's right. Equals 0. So either 2x minus 1 is 0 or x plus 4 is 0. So in this one, I'll add 1 to both sides, then I'll divide both sides by 2. This one, I'll just subtract 4 on both sides. So the x-intercepts of this function, the place where it crosses the x-axis, are the solutions to this quadratic equation. And to solve that equation, we factored it, and then we used the principle of zero products to give us what the two answers for that would be. So that's one way of solving a quadratic equation. Another way is by using something called the principle of square roots. We'll see an application of this in a couple more slides later. But this one, to use a principle of square roots, what you need to have is the square of something on one side and just a plain number on the other side. And if you do that, then you can use the principle of square roots. So this one, let's find the x-intercept of this function. We do that by setting f of x is equal to 0. So we want to know when y is equal to 0. And then I'm going to add 50 to both sides. So I get 50 is equal to x squared. And then I can use this principle of square roots that says if you square root one side to get rid of the square, you can do that as long as you square root the other side. And when you do that, you also need to put a plus or minus right there. So on the right side, I'll have x, and on the left side, I'll have the positive or negative square root of 50. Now, just to practice our square root simplifying skills, square root of 50 is the same as 25 times 2. So I could write this as plus or minus square root of 25 times square root of 2, or the plus or minus 5 root 2. That's probably the answer that I'd like to see. So it's a principle of square roots. You try one. So I'm going to set this to be 0, add 25 to both sides, use the square root principle, remembering my plus or minus there. So then x is equal to either plus or minus square root of 25 is just 5. Let's decimals this and just see what that looks like on a graph. So instead of f of x, I use a y is equal to x squared minus, oh, go over, minus 25, 5. There we go. So you take a look, and sure enough, at this point and that point where it crosses the x-axis, it's 5 and negative 5. Also, you can't really see real well, but the graph does look like a parabola. There, I'll stretch it out. It's sort of interesting. If you grab the axis, you can stretch one way, or if you grab the other axis, you can stretch it as well, just so you can see more of the graph. You can tell I like decimals. Oh, here's some more decimals. Okay, sometimes you might see a question that looks like this, and this is just strictly an equation. There's no y equals or f of x is equal to. It's an equation. But to solve this equation, if it's a quadratic and there's an x term and a constant term, then typically what I want to do is I want to get everything on one side. So I'm going to add 9 to both sides. Then I'll try and factor. So x, it looks like it's a minus 9 and a minus 1. Yeah, that'll work. So either x minus 9 is 0 or x minus 1 is 0. X is 9, x is 1. And you could graph that too. Let's graph it. Okay, so x squared over minus 10x. Oops, 10x. I'm just going to say equals minus 9. See what happens. Equals minus 9. Yeah, it worked. So there's the graph. Interesting how high, it looks like those are just straight lines. Oh, that doesn't look like a very nice graph. Maybe I need to put a y equals in there. Let me just delete some of that. Whoops. X plus 9. Oh, there it's still quadratic right there. So you can see it crosses at 9 and at 1, just like I figured. Okay, another way of solving a quadratic equation is by using the quadratic formula. So here I've got a quadratic equation. The number in front of the x squared is a, the number in front of the x is b, and the constant term is a c. So to solve that, I could try and factor it. I don't know. Yeah, you can probably factor that one. You could try and factor it, or you could maybe try completing the square. Might be tougher. But a quadratic formula will work for any of these. And actually, all of these ways of doing things will work with most every quadratic equation. I guess there's some that you can't factor. But using the quadratic formula, completing the square, and whatever the other one was that we do, the square root principle, that'll work with most all quadratic equations. Okay, so I like when I'm doing this to go minus, and I just put a blank wherever there's a variable. That helps it so I don't make as many mistakes with negative signs. So B in this case is a 5, and this is a 5. A is a 2, and C is a negative 7. a in the bottom is a 2. So now I'll have minus 5 plus or minus the square root of 25. And then minus 4 times 2 is 8, times a negative 7 would be a positive 56. Positive 56 all over 4. Okay, feeling fairly good there. So x is equal to a minus 5 plus or minus the square root of, I think that's 81. Nice. So if that's 81, I can simplify that further because the square root of 81 is just 9 over 4. So let's write out both those answers. So it'd be minus 5 plus 9 over 4 and minus 5 minus 9 over 4. So those two answers, minus 5 plus 9, would be 4 over 4 or 1. Minus 5 minus 9 would be a minus 14 over 4, which I could simplify to minus 7 over 2. So those would be my two answers right there. So if you were to graph that with decimals, that's what you'd get. You should try a quadratic equation one. See how it comes out. Pause and then press play. So x is equal to minus something plus or minus square root of something squared minus 4 times those over that. So b is a negative 13. B negative 13. Okay, and a is 6, and c is a negative 5, and a is a 6. It's always a good idea to check those. I actually went through the whole thing and put in the wrong value for a, and that messed me up. Anyway, so I had to go back and redo it. So be careful that you're matching all those up. Okay, so minus negative 13 would be positive 13, plus or minus, square root. Negative 13 squared is a positive 169. Negative 4 times 6 times negative 5, I think is positive 120. All over 2 times 6 is 12. So x is equal to 13 plus or minus the square root of 289 over 12. And the square root of 289 comes out to bang on 17. Nice. So I can simplify further. So I get my two answers, 13 plus 17 over 12, or x is equal to 13 minus 17 over 12. So this would be 30 over 12, which simplifies, I think 6 will go into everything. 6 will go there, 5, 6 will go there, 2. So 5 halves, or this would be minus 4 over 12, and 4 will go into both of those, so it'll be negative 1 over 3. Let's just confirm that. Let's pull out decimals here. Okay, and let's plug in our stuff. So let's go y is equal to 6x squared over minus 13x minus 5. Okay. Oh, let's zoom in this way. Okay. So 2.5, one of my answers was 5 over 2, that's 2.5. My other answer is negative 0.33, which is negative 1/3. So we're correct. Okay, so that's using the quadratic formula. Another way I can, I think this is our last way, is using complete the square. This is for not the faint of heart, but it involves finding a perfect square and then using the principle of square roots. Let me show you how it's done. What you want to do is isolate the terms that have x's in them. And this works real well if the term that has this term here is even. If it's even, happy day. If it's odd, or if you have a number out front there, you might want to pick a different way of doing it. It's always possible, but it's certainly tougher. Once you've isolated the two x terms, then you don't factor out an x, but what you're trying to do is make a perfect square here, so that later I'll have something squared, so I'll be able to square root it. That's sort of where we're heading. So to get a perfect square, there's just a rule that you use. So you take the minus 4, so let me do it over here. Take minus 4, divide it by 2, and then square that. And you do that every time. So negative 4 divided by 2 is negative 2, and negative 2 all squared is a positive 4. So then what you do is you add 4 to this side. Now you can't just willy-nilly throw in a 4 anywhere you want without compensating for it elsewhere. So you could either subtract a 4 on the same side, or I like to add 4 on the other side. Now I factor this. So when I factor it into two things, things that multiply to 4 add to negative 4, I think are minus 2 and minus 2. Notice that these are the same. That's what we want, because now I have something squared, because I can write both of them as 1 squared. Okay, and this is equal to, that's not that good, a negative number. That's all right. Okay, so this is equal to a negative 3. Now in this one, I'm going to get a complex number, which that might be all right. Anyway, I have something squared is equal to something, so now I can use the square root principle. So I'll square root this side, and that'll cancel the square out. And if I square root that side, I have to square root this side. And when I do it on the right side, I put a plus or minus there. So I have x minus 2 is equal to the square root, or plus or minus square root of negative 3. Now this is getting into complex numbers, which you've probably taken in another math course. I'm still trying to solve for x, so I'll need to add 2 to both sides. So when I add 2 to the right side, we usually write it first. It's a positive 2, so I'll write it there. And then I put a plus or minus square root of negative 3. Looking pretty good there. If you remember your complex numbers, anytime I have a negative under square root, I get rid of the negative and just put an I at the end. So if you were to have done this with the quadratic formula, you would have got the same answer. One interesting thing to note with this is that if I have an I there, then let me show you what happens when you try and graph that. Okay, so let's graph this. So y equals x squared minus 4x minus 4x plus 7 plus 7. So take a look on this graph. You'll notice that the graph doesn't cross the x-axis. Here's the x-axis down here, and it doesn't cross. So because it doesn't cross, that's why your answer comes out to a complex number. Why don't you try complete the square ones? Try that one. Press pause, press play, and then we'll do one final modeling question or application question. Okay, hopefully you've pressed play and you're back in the game. Notice I already isolated the x and the x squared and x term. So now I'm going to take the 8, divide it by 2, and square it. 8 divided by 2 is 4, squared is 16. So I'm adding 16 on this side, adding 16 on this side. When I factor this, I'm going to get x plus 4 times x plus 4. I'm just skipping a step. We'll call that x plus 4 squared is equal to 12. Then I'll use the square root principle, making sure I remember my plus or minus there. So I have x plus 4 is equal to the plus or minus square root of 12. And now I'll subtract 4 from both sides. And I'll put the negative 4 up front here. At that point, I'm feeling awfully good. Again, you could graph that. This one is not complex, so it'll cross the x-axis. But one thing you can do with the 12, again, this is the irrational or the radical kind of questions. 12 is the same thing as 4 times 3. So you'd probably want to simplify that. Square root of 4 is 2 root 3. So for an exact value, I would say my x-intercepts are -4 plus and -2 root 3.
Just one last concept before I show you an example or an application is something called a discriminant. You might have heard about it before, but a discriminant is just something that lets you know what the graph is going to look like. And what it is just the little piece that's underneath the square root sign. So this piece right there. And if that stuff under the square root sign is positive, like shown here, greater than 0, then what happens to the graph is it crosses the graph or the x-axis twice. So there will be 2 real zeros. If what's underneath that square root sign comes out to exactly 0, then what you have is a graph that just comes down and touches 1. And so then, in this case, they would say there's 1 real 0. They're actually, I like to think of them as being 2 real zeros. It's just that they're both the same number. And the last one, if what's underneath the bracket there is less than 0, then the graph that comes up is a graph where the parabola does not cross the x-axis at all. So here you would say you'd have no real zeros. Or another way you could say that is you have 2 imaginary or complex zeros. Here's an example of one. So x squared minus 4x plus 7, you might remember this when we did it on a slide or two ago. So if I wanted to know which of these scenarios it is, all I have to do is just do the b squared minus 4ac. So something squared minus 4 times a times c. B is a -4, a is a 1, and c is a 7. -4 squared is a +16. 4 times 7 is -28. And so when I subtract those, I get a -12. It's a negative number. If it's a negative number, it's less than 0, then it must be one of those. So if you were to graph it, the graph would not cross the x-axis. That's called the discriminant.
Last question to look at is just an applied problem. It's one where hopefully I'll get a quadratic equation that I'll have to solve. It says find the dimensions of a Persian rug whose perimeter is 28 and whose area is 48. Interesting. So perimeter, I know the formula for perimeter is 2 lengths plus 2 w's. And I know the formula for the area is length times width. So they tell me my perimeter is 28. So 28 is equal to 2L plus 2W. Maybe I'm going to simplify that. I'll divide everything by 2. And I'm just looking for a relationship between length and width here. Okay, and they tell me the area is 48. So 48 is equal to L times W. But I need to know what length and width are. So if I have 2 equations, both in the same, using the same variables, what I can do is I can take one of them and I can solve it for one of the variables and then plug that into the other equation. So what I'm going to do is I'm going to subtract W on both sides. And then this I'm going to replace wherever I see an L over in the other formula. So let me just sort of put a line there. So this would be 48 is equal to the length, I'm calling the length 14 minus W times W. See, so I just replaced the length with whatever the length is. Now let's do some stuff to this distributive property. So 14W minus W squared is equal to 48. There I've got a quadratic equation. Woohoo! There's a minus W squared. I'm going to take it to the other side and make it positive. I'm also going to take this to the other side and make it negative. The 48's on the left side already, so it stays as positive. But now I have things equal to 0. So now I can use quadratic formula, I can factor, I could complete the square. I could use any of those tools to try and solve this. I think it can be factored though. Things that multiply to 48 add to 14. I'm thinking 8 and 6. So therefore, the width, W minus 8 is 0, W minus 6 is 0. So either W is 8 or W is 6. Since the width is smaller usually than the length, I'm probably going with the 6. But let's test that out. So if I had my Persian rug, and if the width was 6, so if the width is 6, if I put a width in right there, 14 take away 6 is 8. So that means the length has to be 8. So both lengths are 8, both widths are 6s. So let's see if with those numbers, if that matches up with the 28 and the 48. So the perimeter is 28. So if you add all these numbers up, 8 and 8, 16. 16 plus 12, sure enough, is 28. And area is length times width, so the product of those two is 48. Yep, we must have that right. So in this section, we have looked at recognizing quadratic functions. We've also solved them by factoring, using the square root principle, completing the square, and using the quadratic formula. And we just solved one applied problem. It's important when you're doing these that probably the quadratic formula is the one that you could use with every question. Completing the square you could too, but it's a hard one. So quadratic formula, you can solve any quadratic with that. The easiest of solving ones might be the square root principle or factoring, but it depends on the question. So the more questions you do, the more you're able to determine which of those tools to use when you're trying to solve. All right, go ahead, try the video quiz, the homework, and the real quiz.